is hauling something special.
It can carry what no other airplane can carry in the Air Force. Width, length, weight, you name it, it can get on that thing. This jet can do it like no other jet.
After 2 years of construction at Lockheed Martin in Denver and a few hours in the air, NOAA's GOES-S has finally made it to Kennedy Space Center, where the countdown to T0 begins.
It's always exciting to bring a satellite down to Kennedy Space Center and participate in that whole activity of getting a satellite ready for launch.
Getting it out here and rolling it into the launch processing facility, that was a very big deal for us. It's one of the hugest milestones in any spacecraft program is shipped. It's not easy to transport something like this across the country.
And this is where the rubber meets the road. This is where all these people that have worked on this program for a couple years, it culminates into the excitement of getting ready for what we call launch fever.
And so now, we get to kind of do some of the fun stuff, like put it on a giant airplane and take it to Kennedy Space Center, where we get to prepare it to go onto an Atlas V launch vehicle and launch.
It's the job of NASA's Launch Services Program to get GOES-S into orbit, and they have just a few months to do the final launch preps and inspections before T0 arrives. This is no easy task with a spacecraft of this size and complexity. In spaceflight, there are no second chances. A successful launch is resting on their shoulders. It has to be perfect the first time.
It's very exciting. I love being a part of this, and I love being able to contribute to the spacecraft and to its success.
GOES-S is the second part of a weather satellite upgrade project NOAA is undertaking, destined to save lives by modernizing our weather forecasting ability.
We have a very young team, and this will be their first campaign. So we're trying to put the excitement into that, let them feel what it's like to touch the spacecraft for the last time. Launch operations is time we all get together for one goal, which is launch.
But achieving that goal will not be easy. The road to T0 has just begun.
Third Rock Radio,
America's space station.
Its ongoing mission: explore new worlds of music. Tell the story of those who fly, build, and dream.
Rock radio from space.
Streaming live from thirdrockradio.net.
Good afternoon and welcome to Kennedy Space Center in Florida for the pre-launch news conference for GOES-S. I'm Tori McClendon with NASA Communications, and I'm pleased to be joined by Steve Voelz, Director of NOAA's Satellite and Information Service, Tim Walsh, NOAA's GOES-R Acting System Program Director, Sandra Smalley, Director of the Joint Agency Satellite Division at NASA Headquarters, Tim Dunn, NASA Launch Director, Scott Messer, United Launch Alliance Program Manager for NASA Missions, and Kathy Winters, Launch Weather Officer for the Cape Canaveral Air Force Station, 45th Weather Squadron. Thank you all for joining us. We'll begin with opening comments from our presenters, and then we'll be happy to take your questions. For those of you following on social media, you may ask questions using the hashtag AskGoes on Twitter. For now, we'll begin with Steve Voelz from NOAA. Steve?
Thank you, Tori. It's a real treat to be here again for a GOES-S launch, having been here just 15 months ago for GOES-R. In just 2 days, GOES-S, the second in NOAA's Next Generation Geostationary Operational Environmental Satellite R series, will lift off from Cape Canaveral, Florida, and GOES-S will join GOES-16, which is how we renamed GOES-R once it launched, which was launched last November, November 16, as I mentioned, and NOAA 20, which just last November in 2017, NOAA launched to completing NOAA's new next-generation operational geostationary and polar orbiting satellite fleet. It's been a very busy 18 months or so for NOAA. If you go to the first video, please. When GOES-16, when it reaches orbit, GOES-16 will be known as GOES-S will be known as GOES-17. It will become the GOES-West operational satellite in late 2018, operating opposite of GOES-16, which is in the GOES-East position. In the GOES-West position, GOES-17 will provide coverage from for all the Western United States, Alaska, Hawaii, virtually the entire Pacific Ocean, Mexico, and Central America. Combination of GOES-S in the West and GOES-East gives you almost a hemispherical coverage of the Americas from West Africa to East Asia and all of the space in between. Like GOES-16, GOES-S is a NOAA mission developed in partnership with NASA. NASA has led the development of the satellite and will provide continued and will provide the launch services. NOAA will command and control the satellite and has the responsibility for all the scientific applications of the data and distribute the data to our primary user, the National Weather Service, and for users around the nation and in the entire Western Hemisphere. With the launch of GOES-S, NOAA's fleet of next-generation geostationary satellites is growing, and coupled with the use of our Japanese partners' advanced Himawari satellite, we were able to cover more than half of the planet with the most sophisticated weather forecast technology and observations ever flown from space, in geostationary in particular. For many decades, NOAA satellites have been the backbone of our weather and climate forecasts, but as we've already seen from GOES-16, the GOES-R series is really a quantum leap above any of its NOAA predecessors. If we can go to the next slide, please. You see here a close-up of this is back, I'm sorry. This slide shows you the GOES-East and GOES-West operating in tandem. If you go to the next slide, please, you'll see the close-up of Hurricane Irma as revealed by GOES-16. Looking at the eye of Hurricane Irma, which you'll get to hopefully in a moment, from the Advanced Baseline Imager, which was the primary instrument on GOES-16, as it transits across from the Eastern Caribbean across north of Puerto Rico. The ABI, or the Advanced Baseline Imager on GOES-16, will also be the same flying on GOES-S and for the rest of the satellites in the GOES-R series. GOES-16, even beyond the spectacular imagery we've had, is already proving to be a game changer with much more refined, higher quality data for faster, more accurate weather forecasts, warnings, and alerts. This means, quite frankly, more lives are saved and better environmental information is made available for state and local officials who, for example, may need to make decisions about when to call for evacuations when life-threatening storms or wildfires occur, such as the wildfires that occurred in Southern California in 2017, and the strong storms in particular that produced floods and other deadly mudslides, as we saw in California as well. This is an important situational observation that adds to the forecast and other warnings that we provide. The reach of the GOES-R satellite series extends far beyond our U.S. borders. Since the early 1970s, NOAA has maintained a full, free, and open data policy regarding all of our satellite data, and provided geostationary satellite imagery to countries and organizations throughout the Western Hemisphere. And we've also shared with them all of our polar orbiting satellite constellation data as well. Using our GOES and polar orbiting data together will enable other countries to issue faster, more accurate weather forecasts and to continue and warnings, and in turn we benefit from sharing their data as well in the global partnership we have for observations. In fact, as we look to continue improving our weather forecasts, we've been relying on our partner missions to provide more data for us and to meet our goals as well. In the more than 10 years of hard work that went into the development of the GOES-R series and sacrifice from the GOES-R program community, which includes, in addition to NOAA and NASA, our primary contractor support crew, Lockheed Martin and the Harris Corporation, who are responsible for spacecraft, the Major II instruments, and the ground system, as well as several other companies who have provided the space weather and solar physics measurements as well. These investments over time by people and by funds have been a great dividends to the American people. We look forward very soon to have these 3 brilliant eyes in the sky with GOES 17 added to GOES 16 and NOAA 20 flying now for NOAA and for the nation. Thank you, Tori.
Thank you, Steve. Next, we have Tim Walsh from the GOES-R System Program.
Thank you, Tori. So we just heard Steve talk about the GOES-S as the second in a new series of game-changing geostationary weather satellites. Its coverage will include North America, Central America, and all the way to New Zealand in the Pacific. GOES-S, which will be known as GOES 17 once it achieves geostationary orbit, will provide high-resolution imagery of Alaska and surrounding high-latitude areas previously unavailable or unusable from NOAA's geostationary constellation. When it launches on March 1st and becomes operational later this year, GOES-S will help us see the West in true high definition, and along with the remaining satellites of this series, will extend the life of NOAA's geostationary weather constellation to 2036. Could we bring up the first visual, please? This first visual shows a full disk comparison between the previous GOES satellite on your right and the current GOES satellite, GOES 16, which is in GOES East on your left. You could see just the cadence that we use for full disk imagery is greatly, significantly increased, and we also have significant more spectral and spatial content. This mission underscores NOAA's commitment to flying the best possible geostationary satellites to support and improve the ability of the National Weather Service to forecast weather as accurately as possible, particularly looking at life-threatening conditions that we could all face. Like GOES 16, GOES-S and the remaining satellites in the series, GOES T and U, also will fly 6 new sophisticated instruments. The Advanced Baseline Imager, the ABI, which you just saw some imagery from, is taking some of the most vivid images of weather, climate, and oceans in the Western Hemisphere that we've ever seen. The ABI has 16 spectral bands compared to just 5 on our previous GOES satellites. ABI provides 3 times more spectral information with 4 times the resolution at 5 times the scanning rate of our previous GOES imagers. These satellites are giving us the ability to look at some storms as often as every 30 seconds, allowing forecasters to see storms as they're developing instead of as they've already taken place. Could we bring up the second visual? GOES 16 one-minute imagery is shown of some tornado-producing supercells in southwest Iowa on June 28, 2017. ABI Band 2 is one of our visible bands used for the detection of severe weather. With the better resolution of this band on ABI, which just happens to be our best resolution of all of our ABI bands at a half a kilometer, paired with the more frequent one-minute imagery, it's easier for forecasters to characterize convective clouds from agitated or towering cumulus to mature overshooting tops, which can indicate storm intensification. Then there's the Geostationary Lightning Mapper, or GLM, which on GOES 16 became the first ever operational lightning mapper flown in geostationary orbit. GLM is giving us an accurate picture of total lightning activity, not just cloud to ground, but also cloud to cloud, continually both day and night across the Western Hemisphere. Intensifying severe storms often exhibit a significant increase in total lightning activity, particularly in cloud lightning. Among other applications, this data can help us with air travel safety, helping to inform decisions to route planes around severe weather. Could we please bring up the next visual, please? This time-lapse movie of GOES 16 lightning data covers the afternoon and evening of November 5th, 2017, when a large complex of thunderstorms spanned across Illinois, Indiana, and Ohio. This video is overlaid with aircraft flight tracks, if you look carefully, that show how air traffic interacts with the convective weather, with flights routed around the system or through gaps within the system to reach their destination. The GOES-S satellite also has 4 sophisticated instruments that closely monitor solar activity. and has the potential for space weather to impact systems around the Earth, including GPS, radio communication systems, and even harm critical infrastructure such as power grids. The Solar Ultraviolet Imager, or SUVI, observes and characterizes complex active regions on the sun, including solar flares, which may give rise to coronal mass ejections. Let's please bring up our next visual. GOES-16 SUVI captured this imagery of a powerful solar flare last September 10th, 2017. You can see the flare's onset in the upper right-hand corner, the upper right quadrant, followed by a huge shock wave produced by the flare that you can see rippling across the sun. Pretty tremendous imagery. These new satellites are generating for us 34 new products that are boosting NOAA's ability to accurately forecast weather on the Earth and in space. You've seen some hurricane products and some of the other products. There are also many others. For example, the volcanic gas product has been developed. A volcanic gas product has been developed to identify areas where volcanic gas is present and potentially hazardous, and will ultimately help volcanic gas advisory centers issue more accurate aviation, air quality, and public health warnings. Beyond weather forecasting, GOES-S will be a part of the international satellite-based search and rescue network called SARSAT, which helps save lives with a special transponder on the satellite that can detect extremely faint distress beacons on the Earth. Ground support for these powerful satellites is a major part of our story. The ground system, with two primary locations in Suitland, Maryland, and Wallops Island, Virginia, operates the satellites, receives the data, and brings the data down to the ground, and produces the products and distributes the information in real time. A third facility in Fairmont, West Virginia, is our backup in case a systems or communications failure with either of our primary sites. Once launched, GOES-S will undergo approximately 6 months of testing and validation and will be operational in late 2018 as the new GOES-West satellite. GOES-16 and 17 will then work together to provide fast, high-resolution imagery and data in the majority of the Western Hemisphere, ranging from West Africa all the way to New Zealand, as I said before. Bringing GOES-16 and GOES-S from development to launch has been an incredibly rewarding journey for our team, a true team effort. I want to echo Steve's kudos to the entire GOES-R program team for their stellar contributions to get us to this day. Thank you. Tori?
Thank you. Now we'll go to Sandra Smalley with the Joint Agency Satellite Division.
Good afternoon. I'm thrilled to be here today to talk to you about the GOES-R series program. It's a very exciting and very important mission, as you've heard from my fellow panelists, continuing to transform weather forecasting. The launch of GOES-S spacecraft continues over 40 years of partnership between NOAA and NASA, collaborating on geostationary operational environmental satellites. The Joint Agency Satellite Division within NASA Science Mission Directorate plays a unique role. We bring to bear NASA's expertise in flight and ground system development, program and project management to support space flight development on the GOES system. The partnership began when NASA launched the first operational GOES satellite, GOES-1, on October 16, 1975. And now, 42 years later, GOES will launch on March 1st. Aside from possibly launch and first light, the video that you're about to see is one of the most exciting times for a satellite. It's actually when the satellite arrives here at Kennedy Space Center and we're getting ready to launch. Please cue the video. So here you see the GOES satellite aboard a Air Force C-5 aircraft, which landed at Kennedy Space Center's shuttle landing facility on December 4th, 2017, after taking off from Buckley Air Force Base. The GOES-S satellite was moved to the Astrotech processing facility via semi-truck that was loaded onto, it was originally loaded at the Lockheed Martin Waterton facility. Upon arrival at Astrotech, the satellite was removed from its environmentally controlled shipping container and readied for launch. After final test and pre-launch preparations, the GOES-S satellite was integrated atop the ULO payload adapter. That's what you see happening right there. And then finally, it's encapsulated in its Atlas V fairing, as you see here. And now, GOES-S is ready for launch. So, a lot of work has gone into getting GOES-R ready for orbit. I would like to recognize extraordinary team members that brought this mission together, beginning with Lockheed Martin for developing the spacecraft and two instruments, the GLM and SUVI. Harris Corporation for developing the ABI and ground system, University of Colorado Laboratory for Atmospheres and Space Physics for developing EXIS, Assurance Technology Corporation for developing SEIS, McIntyre Electronic Design Associates for developing the magnetometer, the Kennedy Space Center's Launch Services Program for acquiring the Atlas V launch vehicle, the United Launch Alliance for providing the Atlas V 541 launch vehicle, and NASA Goddard Space Flight Center for providing the program and project management and engineering expertise to the GOES-R series program. Thank you all for your team's hard work and dedication to delivering this amazing next-generation geostationary satellite. And we'll continue to provide weather forecasters with the information they need to protect the public and the nation. So I want to say, go Atlas, go Centaur, GOES-S.
Thank you, Sandra. Next, we have Tim Dunn, NASA Launch Director.
Thank you, Tori. I'm proud to be here today representing the women and men of NASA's Launch Services Program, and I'm very excited to be the launch director for the GOES-S mission. Working alongside our United Launch Alliance colleagues, the engineers and analysts of NASA LSP take great pride in launching this next-generation weather satellite. As a Floridian, I want to give my personal thanks to my three colleagues to my right for this new hurricane tracking and data capability that this generation of GOES spacecraft brings us. NASA has a terrific record flying on the Atlas V. We've successfully launched 15 missions on this magnificent rocket. Missions to Pluto, Jupiter, the Moon, the Sun, the radiation belts, 3 spacecraft to Mars, the asteroid Bennu, as well as GOES-S's predecessor GOES-R and 3 TDRS spacecraft. GOES-S will be NASA's 16th mission on an Atlas V and the 76th Atlas V launch overall. GOES-S will launch on an Atlas V 541 configuration. The 4 means 4 solid rocket boosters added, so it's going to be a big one. We'll launch from Space Launch Complex 41. Complex 41 has hosted 61 Atlas V launches to date. Now I'd like to show a video with some great shots of the ULA crew receiving and assembling the Atlas V launch vehicle and mating GOES-S. Please roll the video. Here you see the arrival at the Cape in January of the Atlas V first stage booster and second stage Centaur. These stages are manufactured at ULA's factory in Decatur, Alabama, and transported to the Cape via the Mariner ship. Here you see the offload and transport across the Cape into pre-launch processing facilities. That's a great shot of the second stage Centaur there at its off-site vehicle processing facility. Here we are early on the morning of January 31st. This is the first stage booster being rolled out to the vertical integration facility at Complex 41, and that was a great drone shot of the erection of the first stage booster. This is one of 4 solid rocket boosters that were put up after booster erection, and that is the second stage stack coming out to be mated. And those are also some great drone shots. New capability that we have to document the processing. Here is the encapsulated GOES-S spacecraft rolling out early on the morning of the 16th of February out to Complex 41's vertical integration facility for erection and mate to the top of the Atlas V Centaur. The GOES-S launch campaign has been very exciting. Over the last 11 days since that spacecraft mate you just saw, the Atlas V team has been busy with launch preps. Last week, we performed the integrated systems test between the spacecraft and the rocket, and that was very successful. Also, the combined NASA and ULA launch team held our flight readiness review last Friday, where we assessed all processing and pre-launch preps for the mission. That went well. Then after FRR on Friday afternoon, we performed the mission dress rehearsal, where we exercised and prepared the entire ULA, NASA, NOAA, Lockheed Martin, and Air Force Atlas V launch team. Just this morning, we conducted the launch readiness review for GOES-S. Senior managers from KSC, Goddard Space Flight Center, NOAA, and headquarters, as well as our ULA and Air Force partners, assess readiness for launch. Tomorrow, we will begin our final launch preps at 10 a.m. Eastern Time by rolling the Atlas V on its mobile launch platform approximately 1/4 mile from the VIF to the launch pad at Complex 41. Then the launch team will load approximately 26,000 gallons of RP-1 fuel onto the first stage. On Thursday, the launch crew will begin arriving on console in the morning to begin the power-on sequence for both the GOES spacecraft and the Atlas rocket. The crew will perform final preps of Atlas V power-on and electrical checks, followed Thursday afternoon by loading supercold cryogenic propellants on board the Atlas V. Liquid oxygen into the oxidizer tanks of the first and second stages, and then liquid hydrogen into the fuel tank of the second stage Centaur. Final flight control tests will be performed along with final tests with Eastern Range instrumentation, and then we'll be ready for launch Thursday afternoon at 5:02 p.m. Eastern Time with a 2-hour launch window. To summarize, the spacecraft, the Atlas V rocket, and range equipment are all ready, and the combined government and contractor launch team is prepared to launch GOES-S, a critical national asset for weather data. Back to you, Tori.
Thank you, Tim. Next is Scott Messer from United Launch Alliance.
Thank you, Tori. So on behalf of the men and women of United Launch Alliance, just want to say how excited we are to be here today as we prepare to launch this critical NASA NOAA payload, GOES-S. GOES-S will be the third launch for ULA in 2018 and the 126th successful launch overall since the company was formed in 2006. Standing proud out on the launch platform, the vehicle, the Atlas 541, as Tim mentioned, stands 197 feet tall, 5-meter fairing, and 4 solid rocket boosters. This configuration was first launched in November of 2011 and has had 5 launches to date, with GOES-S being the 6th. We've launched, I think, 3 DoD satellites, the previous GOES-R, and of course the Mars Curiosity rover were all launched on this particular configuration. Weighing in at just a little over 1 million pounds and putting off about 2.25 million pounds of thrust, the vehicle will lift off on the 1st. And we have a little video that we like to show that shows kind of the sequence of events that will occur after liftoff. So if we could roll that video.
The following profile details the important events of this mission using approximate times.
4, 3, 2, 1. And liftoff.
The Atlas V RD-180 main engine and 4 solid rocket boosters ignite to generate the 2.25 million pounds of thrust to lift the rocket away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 35 seconds. At 47 seconds, the vehicle experiences maximum dynamic pressure. All 4 solid rocket boosters, or SRBs, are jettisoned at 1 minute 50 seconds. 1 minute 40 seconds later, the payload fairing is jettisoned. Approaching booster engine cutoff, the Atlas V burns propellant at a rate of 1,856 pounds per second, traveling at over 13,340 miles per hour, and is located 83 miles in altitude and 267 miles downrange. Booster engine cutoff occurs 4 minutes 22 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The vehicle now weighs a little more than 5% of what it did at liftoff 4.5 minutes earlier. 10 seconds after booster separation, the first Centaur main engine start takes place. Cutoff of the Centaur main engine occurs just over 12 minutes after launch. The mission now enters a nearly 10.5-minute coast phase. At 22 minutes 38 seconds, the Centaur main engine is restarted. This burn will last 5.5 minutes. Following the second Centaur main engine start, at 28 minutes 9 seconds, the mission now enters a 3-hour coast phase. Just over 3 hours 28 minutes after liftoff, the Centaur is started for a third and final burn. Approximately a minute and a half later, final cutoff of the Centaur main engine occurs. At 3 hours 32 minutes and 31 seconds, Centaur releases the GOES-S satellite for NOAA and NASA.
Great. I don't know about you, but I get excited for Thursday's launch just watching that. That was the GOES-R footage that you saw initially there. It was late in the evening. We hope that our GOES-S launch will occur at 5:02 on Thursday, and it'll be daylight, and you'll be able to see all of that stuff there. Again, we at United Launch Alliance are proud to deliver the GOES-S satellite to its orbit and to play that small part in the critical weather forecasting, storm tracking, and meteorological research that GOES will do. As was mentioned, GOES launched, the first GOES launch was in 1975, 42 years ago, and we at United Launch Alliance are proud that either our current or one of our heritage vehicles has launched every GOES satellite that has ever launched. So we're thrilled to play an important part in the GOES constellation. We will continue to do everything to reliably deliver the GOES satellite as well as all of our nation's critical payloads to orbit with 100% mission success, and want to say thanks to all of our mission partners, and the entire team looks forward to a successful launch Thursday night. And as Sandra said, go Atlas, go Centaur, and go GOES-S. Back to you, Tori.
Thank you. Next up, we have Kathy Winters, the Launch Weather Officer.
Well, I'm extremely happy to say that we have good weather for the GOES-S weather satellite launch. So thank you very much for this GOES satellite. We've really enjoyed GOES-16, especially last year. It was very important during hurricane season, and we're really excited about this launch as well. Weather does look great for launch, also for the rollout tomorrow. So we're going to roll out in good weather. There's a front that's actually moving through today, but it's not active at all. As you can see outside, it's sunny, partly cloudy conditions. There's just slight chances of isolated showers once in a while during the day. Today, also tomorrow, that boundary is going to actually move back to the north. But again, there's no upper level energy with it, so it's not really making any weather in the area. And so tomorrow, winds are only going to be gusting about 12 knots for the roll. Really good weather. As we go into Thursday for launch, we do have a little bit windier conditions, but nothing that's going to violate our launch constraints. So again, favorable weather, and if we happen to move even another day, weather remains favorable. Even with the front moving through Friday morning, it's again doesn't have a lot of energy or activity with it. So overall, a very nice chance for good weather for the next several days. Let's go ahead and look at the satellites. You can see what I'm talking about. You can see that there is a front that's pushed through Florida, and it's not making any weather really. We just had maybe a slight chance for a shower here and there, but really overall great weather. Just slightly breezy today with winds gusting in the upper teens, and that's going to come down tomorrow as that boundary moves back up, but with no fanfare at all. So going into our weather will be good for the roll, and then going into our launch day forecast, which you'll see on the next slide here. And we're just looking at scattered skies, unrestricted visibility. There's a little bit of wind out there, but it's not an issue for launch. Winds gusting to 26 knots from the west-southwest. The temperature's going to be cooler as we get this windy, a little bit windier conditions and getting into the evening hours. We're getting up to the 80s during the day, but by launch time, 77 degrees. And the only concerns, and they're just slight, is cumulus clouds and ground winds, and there's just a 20% chance of violating any of our weather launch commit criteria. If we happen to delay another day, weather still looks great. The winds actually come down, so the only concern this day would be just a 20% chance of violating constraints due to cumulus clouds. But again, overall, very favorable weather. And again, thank you for the GOES-S satellite.
Thank you, Kathy. At this time, we'll take questions from the audience. Again, if you're following us on social media, you may ask questions using the hashtag AskGOES on Twitter. We also have a phone bridge for the media who wish to call in. So for those of you in the room, please raise your hand and wait for the microphone. Please state your name and affiliation and to whom you're directing your question. And we'll go ahead and take a question on the front row with Bill.
Hi, Bill Horowitz, CBS News. For Tim, I guess, just on launch dates, do you have Thursday and Friday on the range? And can you tell us, we were a little concerned that perhaps Falcon 9 they were talking about launching that one early Thursday, like 17 hours before you guys. I didn't think you could roll out if they were doing that for, possible plume contamination or whatever. Can you just talk about the strategy of how y'all schedule launches like that, and if you have both days in a row? Thanks.
Yes, sure. So we are confirmed on the range for both March 1st and March 2nd. So that's the typical range reservation. And we were aware of SpaceX, due to their fact that they didn't launch. They had requested March 1st, early morning March 1st. We understand that that has not been approved by the range, so we're clear for our opportunity on the 1st. We were doing initial assessments of being in an exposed condition. Obviously, we'd need some time to take a look at that to assess all the risks that it would be incurred on GOES-S as well as the Atlas V rocket. So we're not in that condition right now, and we look forward to launch on Thursday afternoon.
Next, we'll take a question from Marcia Dunn.
Marcia Dunn, Associated Press for Mr. Volz. Could you explain in general terms how much of a boon, a bonus, how lucky everyone was as Hurricane Irma and Harvey came, through the United States last summer, and how helpful, how much did 16 offer that would not have been there had it not been up and working?
Time you have. It was really remarkable. The services that the Legacy GOES satellites have been providing were ready and prepared to do all the operational services, and the National Weather Service and all of our other responders were ready to work with those information sets. GOES 16 was in a checkout mode still until the end of last year, so it was just in its test and development phase. But the impact of the imagery, the resolution, the high spectral content, the information content, we're seeing in snippets and all over the place during the multiple storms. I'll give a couple of simple examples. Certainly when Hurricane Harvey landed in Houston, we were able to, with the high resolution and the high repeat refresh rate on GOES 16, able to indicate the position and the tracking of the eye wall and the severe storms on a mile-by-mile basis and minute-by-minute time frame, so that we can be in close coordination with the emergency managers, the first responders, to actually give them almost tactical information on where the eye was so they can move in response to that and plan around that in a way that we would not have been able to do previously. In Puerto Rico, when Hurricane Maria hit Puerto Rico and effectively took out the entire power grid, that was noticeable. But what it did, it took out our weather radar that was on the island as well. So they had no ground-based radar of consequence to cover while the main storm is still flowing through there and while the significant impacts are still being felt. But the accuracy and the precision of the GOES 16 data set coming down in near real time and being transmitted to the responders and the forecasters in the region, we're able to use as a proxy some of the GOES 16 radar data, not radar, but the GOES 16 imagery and products to understand wind speeds and where the storms were occurring and where the significant events were happening in near real time as well. Those are just two simple examples, but the other part is that the hemispherical imagery that you were able to see. At one point, we had 3 hurricanes at once, all happening, and panning back and seeing all that, and having the resolution, the precision to be able to track and understand and monitor all 3 of those with a precision that you were able to do maybe one at a time if you were to focus in previously, was really something that allowed the hurricane forecasters in the National Hurricane Center to really handle that influx of multiple storms, multiple events at once, and partition out the data to treat them all as serious storms as they were simultaneously in a way that would have been challenging with the previous resolution of the Legacy system. So.
Hi, Ken Kramer, Rocket STEM on Space Up Close. For Kathy Winters, I've got actually a very similar question for you as a practicing meteorologist. What difference are you seeing between the Legacy GOES and GOES 16 for general weather as well as launch weather forecasts? Thanks.
Well, for example, just the resolution that you get on the new GOES, what we're using is GOES East now, GOES 16. You can see those. You saw that one video with the overshooting tops of storms. You can really get that, and you get it more quickly. You get more temporal resolution. So instead of waiting 15 minutes for a picture, you can do it much quicker, 5 minutes, and they even can bring it down even shorter than that. So you can really see the overshooting tops, which is an indication of tornadic activity. So you're getting a lot more information more quickly, and you're getting it really good resolution more quickly. And then also for hurricanes, the rapid intensification is much more clear. You could really see the structure of the hurricanes so well. And I'm sure the Hurricane Center, I know they're just really going to be using this for all kinds of abilities to be able to observe storms. And the better you can observe a hurricane, the better you can model the weather and forecast the hurricane as well. So better observations lead to better forecasts. And another thing that we're really looking forward to is space weather, the instrumentation of the space weather, because we use that for launch weather forecasting. There's space weather constraints, and so we're going to be monitoring that with the space weather sensors and also the lightning mapper. You know, it's hard to get lightning data offshore over the water. So now we have our in-cloud system that does it locally, but sometimes you can get an AMVO cloud that's streaming all the way in from the Gulf of Mexico, and we can actually now see lightning if it's in that location that we couldn't see before. So there's a lot of uses, not just for all the meteorologists out there, but even for our specific launch forecasting. And one final thing I'd like to mention, I was out in California lately, back in December, when those wildfires broke out, and GOES West, and now the new GOES 17 will provide much better resolution for the wildfires, which will hopefully save lives. People are evacuating their homes, and now you can actually detect it earlier and detect the growth of the storm better, or the wildfire better. So there's a lot of really good public safety uses for this as well as for launch forecasting.
Next, we'll take a question from social media.
This question comes in from Antonio on Twitter, and I think probably for Dr. Volz or Mr. Walsh. When will GOES S send back its first images? When will we see the first images from GOES S?
Okay, after we launch, it takes about 2 weeks to get to on orbit, to the geostationary orbit, and then we spend about a month outgassing our instruments, letting basically effluents go off the instruments, and then eventually we start turning them on. So it'll be a couple months afterwards, roughly in May, when we start seeing our first data from the instruments, and then as I mentioned earlier, we'll spend about 6 months evaluating that data, perfecting the products, validating the products, and getting ready with the National Weather Service to release that data into operations. Okay.
Thank you. At this time, 2 of our participants will need to step out to go to another GOES S related meeting. So we'll go ahead and excuse them if they're ready.
If there's not I can do one more follow-up to the question about impact of GOES 17.
Please go ahead.
One of the things, we focus on what you can see with the satellite. You see the storms, you see the hurricanes, et cetera. But one of the benefits of being able to look at a large storm like Harvey, which went all the way from northern Mexico to the Tennessee and Kentucky, was to be able to use that large synoptic view and to understand where there aren't issues that you have to deal with as well. So if you're FEMA and you need to deploy resources to prepare for floods or emergency or water or emergency supplies, it's just as important to know where the floods occur as where they're not occurring. So what GOES 16 is able to do with its precision and its accuracy, and combined with our polar satellites, which provide flood mapping and flood forecasting, like the VIIRS instrument that's on the JPSS and the SUMI NPP series, allowed NOAA to provide that information to FEMA, say these are areas where there is likely to be flooding, these are areas where there's not, so that they don't have to worry about eastern Tennessee, because that's a area which to earlier models might have been susceptible to flooding, but it's not happening this time, so they can focus their energy where it really is needed. And that discrimination between the problem and non-problem areas is really essential to manage the limited resources that are available in a large event that occurs like a major hurricane. So we focus, I say, a lot on what you do see, but what you don't see and you don't have to worry about is a great relief to managers who have to figure out where they spend the resources that they do have.
Hi, hi, Emery Kelly with Florida Today and USA Today. I think it was mentioned before that there is at least some overlap between 16 and 17. geographically. What is that eastern boundary, if you will? In other words, if there's another major hurricane on the East Coast, can they both look at the storm, and is there an advantage to that?
Sure. I think there was a visual earlier by Dr. Voles used of the two look angles. We can see primarily most of CONUS with both imagers easily. Once you start looking at a very oblique angle to the Caribbean and others from the GOES West location, we're at 137 west longitude when we're operational. It can be used for some weather in the Caribbean, but we are primarily looking at the Eastern Pacific, the hurricanes in that location. There's a lot of weather that's currently not being seen by the data or the types of instruments that we're flying on GOES 16, so that's going to be huge. But yes, there's a lot of overlap over mostly CONUS. I will say the next panel that's coming in at 2:30 might have some better imagery examples, but we do have a lot of overlap region. But as you can see from online, we have some good images of what the CONUS imagery will look like, and it is rather oblique. It is at a very shallow angle. So our primary instrument, our primary satellite to look at the Caribbean is GOES East, of course. But the other thing I did want to mention is that some of the things that we'll see with GOES West particularly is, I think from the geostationary location, the higher latitudes have been somewhat underserved. You know, we could not see with the spatial resolution that we have in the old imagers a lot of Alaska, for instance. And when we were testing GOES 16, we noted a lot of ice movements in the Hudson Bay, for example, because we were testing it over 90 degrees west longitude, which is roughly New Orleans. And so we were able to see some high latitude information that we previously could not see. So there's a lot of new information that we're very excited about seeing from the western location. So thank you.
And there's an added benefit of overlap as well, in that, as Tim was mentioning, you cover most of the continental U.S. with both satellites, mostly with the East, but you now have stereoscopic viewing of a lot of the phenomena of interest in the middle U.S. And having that viewing with the resolution and the extra information content of GOES 16 and 17 is an area of great scientific and research interest to see what other information we can extract other than just staring down and the images that we have historically. Now we have high-resolution side viewing. Some major storm events be occurring that you have a side view from two satellites, which can give you a different way of imaging and understanding storm intensification and other generation, which is a research area. It's not something we promise as a necessary delivery of GOES 16, that wasn't, or 17, but it is definitely a capability that we expect to be yielding great interest and great profit to us as we take advantage of the data of both satellites.
One last comment on that, just to go back a little bit. One of the incredible flexibilities of the ABI, the Advanced Baseline Imager, is that we have an imaging sequence where we look at the full disk every 15 minutes, CONUS every 5 minutes, and then we have the ability to joystick in these two, what we call mesoscale regions of 1,000 by 1,000 kilometers. So we could look at 4 different interesting, meteorological or other phenomena once we have the 2 satellites on orbit. I think that'll be something that really we have just started to scratch the surface with the GOES 16 data. So whether it's hurricanes or forest fires or other things. So.
Thank you. We'll go ahead and take another question from social media.
This comes from Matt on Twitter. Mr. Walsh, you mentioned about GOES 16 helping with aviation forecasting in regard to the GLM. What other applications does this new satellite series have for the airlines and for forecasting the weather and flight route planning?
Well, besides observing the normal imaging that you'd get from the geostationary location for what we call the Earth pointing or nadir pointing instruments, you also get a lot more knowledge about the space weather. And I think it was referred to earlier about some of the knowledge we'll get with advanced higher resolution space weather, whether it's what we call in situ, measuring the local environment around the satellite, the magnetosphere, which is another area of the magnetic field effect in the area of the satellite, but also looking at everything from the surface of the sun all the way to the Earth. A lot of those effects can impact things like radio communications, GPS performance, and other things. So a lot of this data will be used by the National Weather Service has a group called the Space Weather Prediction Center in Boulder, Colorado. They utilize our data to issue warnings and other information to the, among many other groups, the airlines. And airlines may vector their airline routes differently based on space environmental data. So that's just one example.
And I'll give one other example. Fog is of interest to airports and airlines, and airports have to shut down because of heavy fog at times. And with the lower resolution of the existing satellites, there might be a pixel which is 10 kilometers in size, which covers an airport and all around it, where with a higher resolution it goes, where you have 1 or 2 kilometers or better, you can pinpoint where there's fog and where there isn't. And there are examples, one example during the test phase at San Francisco Airport, where we were able to open the airport much sooner, have it closed down in a much shorter duration of time, because we could pinpoint the fog locations, and the airport could sortie airplanes in and out much more rapidly. And in that, I think it was one day, one event at San Francisco Airport, there was about $100,000 savings to the airlines because they could make schedules that they couldn't have made otherwise, in case money not lost to delays and the like. Now add that to, and that was a provisional product during a test phase, add that to 2 satellites doing that across the entire CONUS on a regular basis, you come up with significant impacts and improvements, efficiencies for airline traffic around areas prone to fog.
Thank you. A question in the back of the room?
Hi, Nick Stewart, KGAN News. A question for other than NOAA people here. The question I have is, we talk a lot about hurricanes and that kind of stuff in the Atlantic Ocean, but a lot of the weather that kind of impacts the western United States and the Midwest United States, all those big mid-latitude storms that kind of originate in the Pacific Ocean. So can you elaborate a little bit more on how having all that high-resolution data over that Pacific Ocean kind of help forecast not only for the western United States, but also for those in the east as well?
I could start.
Go ahead, Tim.
So I like to think of it as the GOES East, or the GOES 16, really gave us a sense of a lot of the tropical storms coming from the east to the west. But as you pointed out, a lot of the data, a lot of the weather formations, of course, are going from west to east. And so this will give us kind of the whole picture, which to me is really valuable as far as we're stitching together the GOES 16 and then in the future GOES 17. And we'll see data, we'll see information, weather formation starting all the way out into the eastern, I should say the western Pacific, and watching that formation occur. I think together with that imagery stitched together, we also, I should really point out that our partners in Japan, the Japanese Meteorological Agency, or JMA, has a similar type imager to what we're flying on GOES 16 and 17. And using those 3 imagers together, we'll see a large swath or a large chunk of the Earth's sphere for weather information.
Yeah. And I was going to say, I'll add one other example. The atmospheric rivers that have made the press recently in terms of how water gets to the Pacific coast and in California, with the resolution and precision you get from a GOES 17, monitoring those and tracking and understanding those much better, higher resolution, much more information, is a phenomenon that is definitely of interest to the meteorologist.
We'll go back to Marcia.
Marcia Dunn, AP again for Dr. Volz. Quickly, the next 2 NOAA satellites of the series, when are they targeted for liftoff? And as I recall with Therma, there was a lot of uncertainty where it was going to hit Florida, and then it kept changing direction. And was 16 useful in helping with that kind of tracking uncertainty, or is there some things about hurricanes that even the best satellites can't really pinpoint?
Well, I'm a satellite guy, so I think satellites can answer every question at some point. But I think that second question is probably better directed at Dr. Uccellini, who's going to be on the panel afterwards to talk about the National Weather Service Director. On the first question, it's a 4-satellite constellation we have with GOES R, S, T, and U. This is the second. The third and fourth are in development. We are currently targeted to launch GOES T. We have a launch readiness date of 2020, and GOES U of 2024, I believe. Yep. April 2024. So that's the target and the plan date for those. They're in advanced development stages right now. And seriously, on the other question, I think there are things that you look to use a geostationary orbiter for, and things you use a lower Earth orbit or a polar satellite for. And I'm not the best person to answer unless you would. I would punt that question to the next panel, where you have the Weather Service can give you a much more comprehensive answer on that.
We'll take another question from Ken.
Hi, for Sandra, can you tell us, beyond GOES, what's NASA and NOAA working on for the next generation of satellites?
Sure. So NASA, as I mentioned, enjoys a very long-term partnership with NOAA, and it encompasses not only the work that we're doing here as part of the reimbursable efforts, whereby we build the satellites for them and launch them and commission them and then hand them over for operation, and that build and all is actually an integrated programmatic team that is comprised of both NOAA and NASA folks. But in addition to that, both in the earth science arena as well as the heliophysics arena, there are a lot of synergistic types of activities. We have very different missions, but there's synergy whereby we use the same data. So on the NASA side, we use it to support the research activities that we're doing on the NOAA side, they'll use it to support their operational activities. And so we are continuing to leverage both those activities moving forward. We're looking at more effective and efficient ways to do so, not only leveraging our partnership, but also the international partners and commercial providers moving forward. Steve, is there anything you'd like to add?
I would just say that the complementary roles of NASA and NOAA are really essential to both our successes. We provide, NASA provides that sort of stretch technology development and the next generation capabilities and instruments. NOAA provides the effectively the assured provision of a certain quantity of data for a long period of time, which is essential for researchers to know what they can count on and what they can add to. So the baseline data set that NOAA provides with GOES and JPSS are essential, I think, to NASA's being able to develop experimental missions that complement that and add value to those data sets so that together we have a much more synoptic view of the Earth in a comprehensive way. From a technology perspective, we really rely on that research in technology, in applications, and in fundamental understanding of the Earth to see where we want to target our longer-term operational missions as well into the future.
We'll go ahead and take another question from social media.
This comes to us from the Weather Boy. With GOES-R operational as GOES East and GOES-S to eventually become GOES West, are there any learnings from either that will result in any tweaks or updates to GOES-T or GOES-U?
I can take that.
You take that one, and then I'll follow.
Okay, there's a couple things we learned from GOES-16's early orbit experience. I mentioned that there's a couple in situ or local environmental sensors. One of them is the magnetometer. We measured the Earth's magnetic field around the satellite. We noted early on that the magnetometer, as it was accommodated on the GOES-16 satellite, was not providing the data as well as we would like. So we've modified GOES-S, T, and U to provide what we believe is going to be a better accommodation for this sensor. That's one example. We also modified other parts of the satellite just to really optimize the performance on orbit. We've added some blanketing, did some extra grounding and shielding of the spacecraft or various instruments. But in general, they are very similar. We have learned a lot of tweaks as we bring the satellite to operations. We've modified our testing experience. It took about a full year to test GOES-16, and that was working with our partners in the product world, the National Weather Service and others. We're going to do it now in 6 months. So we've modified our commissioning phase to about half the time.
But essentially, the 4-satellite constellation is the same suite of instruments with the same benchmark performance. We've learned from historically the way to manage cost and performance is to develop multiple satellites at one time. Not all in parallel, but in serial, so you don't have the constant churn of changing requirements, changing specifications, and having a cost uncertainty in the development. But back to the previous point about the NASA-NOAA relationship, having the benchmark performance from these satellites, we know there are more observations that are useful to our mission. And now knowing these are there, we can add complementary individual measurements. We might look at very targeted specific science areas, which count on the presence of GOES ABI for the next 20 years, so that they can add those two together to create merged or added value data products. And that's really the future, as NOAA is looking at its next generation as the architecture of the future, is not just building a better instrument, but integrating and operating a better system where all these instruments and observations are integrated and work together. So when the data flow coming out is not tailored to one individual instrument, it's a seamless data flow from multiple observations.
So as we wrap up, we'll take one final question from social media.
Is there anything you're seeing from GOES-16 that was unexpected or better than expected?
That's probably a good question for several of us here. I'll just give you my short one, which is I think the impact of the visualization, the actual videos, the movies coming out, is really visceral, and it's something you couldn't put into the specification. You're going to get a lot more information from a movie as opposed from a bunch of stills. But it does it allows the researchers to see the dynamics in a way that just looking at numbers just doesn't reveal. So I think the visual impact is really just remarkable, and the insight it gives you on what phenomena are occurring that you just don't get from data. And that's the thing that comes to my mind the most.
So one thing I would mention is I recently went to the American Meteorological Society annual meeting. I'm an engineer. I'm not a meteorologist. So I was amazed by what I saw out there and the excitement that I saw from GOES-16, and specifically the fire products that we've seen. We've seen some examples where, I think it was alluded to earlier, in California during the fall region or fall time frame of last year, we're seeing fires before they're reported on the ground. Sometimes we're reporting fires that 911 has not yet been called. So I think some of the information we're getting on GOES from 22,300 miles away is giving us information on the ground that's incredibly vital. So.
Meteorologist, please.
One thing that keeps going through my mind is the eye wall replacement cycles during hurricanes, just the way you can see those. And when that's happening, it could be a major hurricane, but, it's going to weaken for the next 12 to 16 hours. And, seeing that within the resolution that you see it on the new satellite, you can actually really pick it up. And so those are the kind of things Hurricane Center, I know, is going to be really, enjoying with the new, that they have been enjoying actually already, looking at the imagery from the GOES 16, and they'll be using it also for the Pacific as well for the new GOES S.
Thank you, Kathy. Thank you all for joining us today. That's all the time that we have. The next televised event for this mission will be the GOES S Science Briefing, which will begin at 2:30 Eastern. You can also tune in to the live coverage at nasa.gov/NTV. You can also follow us on Twitter using @NoSatellites. Thank you very much.